Right, today we've got a question on the chromatography required practical, which is something that you need to know if you're doing combined and triple, and this is from chemistry paper 2. Required practicals always come up in some form or another, so this is really important that you know this, and chromatography is quite a popular required practical to come up. So this is quite a long question. There's 3 pages worth of questions, so it's going to be about 6 or 7 minute video, I reckon. A student investigated the colours in brown ink using chromatography. This is the apparatus. So they've got some sort of tank in which they've poured a solvent. So that could be water or it could be ethanol. They're the 2 most common solvents to use. And then they've drawn a line in ink. And on that line, they've placed a brown ink dot. And then they've also placed a yellow, green, blue and red coloured dot. So this ink contains different colours. So ink is a mixture, so it's got different colours in it. And then this chromatography is then placed into the solvent, and we are told that the students made 2 errors, and we've got to work out what those mistakes are and what problem they would cause. So the first problem is that this line here is being drawn in ink and it should be drawn in pencil. And the reason that's a problem if it's in ink, because that ink is going to also be soluble and potentially, well, if it's in the solvent, it will mix with the solvent and it will confuse the results. So error 1, start line is drawn in ink. And that's a problem because the ink can mix with the solvent. Now, the next problem is that the solvent line here should be below the start line. And the reason for that is because otherwise all these colours, all these ink dots are going to just dissolve straight away if they're soluble, which we will assume they are. They'll all just dissolve, they'll mix in with the solvent and they won't migrate up the paper. You need to make sure that the solvent line isn't too high so it doesn't go above the start line. So solvent is above the start line. That's a problem because the colours will dissolve. So in this practical, you need to make sure it goes above the solvent line, this start line, and then what will happen is the solvent will soak into the paper. It will gradually seep up the paper. It will bring those dots with it. So the dots will dissolve in the water that's seeping up the paper, that's absorbed in the paper. You don't want it to completely dissolve in the solvent itself. A different student sets up the apparatus correctly. Figure 2 shows results. So here's our brown ink. So this is our kind of sample with the unknown colours in it. And then these are what we call our known samples. So this person would compare the dots 1, 2, 3, 4 with the known sample, and that can be used to tell us which inks are in brown. So give 2 conclusions the student can make from figure 2. So the first conclusion would be to know what is actually in brown ink. So you can see that the yellow is matched with this position, and also we have a match with the red and the blue. So we can see that brown ink contains yellow, red and blue ink. We can also conclude that it doesn't contain green because we don't have a dot where green would be. We can also conclude that it contains an unknown colour. So this colour here is not matched by anything, so we would not know that colour. So brown ink contains an unknown colour would be another conclusion. And we could also conclude that blue colour is the most soluble because it migrates the furthest. The green is the least soluble. Not that the green is in the brown ink, but in the inks that are in brown, red is the least soluble. So when a colour moves further up the chromatography paper, it means it's more soluble. When it moves a shorter distance, it's less soluble. Question 3, why was the green colour still on the start line at the end of the experiment? So the green hasn't moved. That would be because the green is insoluble, so it's not going to dissolve into the solvent, so it won't travel up the paper in the solvent. The student calculated the RF value of a colour to be 0.24. The colour moved 1.8 centimetre from the start line. We have to calculate the distance the solvent moved, and we have to use this equation. So the RF value is a ratio, if you like, between 0 and 1. A value of 0 would mean that the colour is not at all soluble, like green, and a higher value closer to 1 would mean that the colour is more soluble. So the closer to the actual solvent front, the solvent line that it moves up to, would give you a ratio value of 1, RF value of 1. So let's use this equation. So we need to substitute in our values. So the colour moved 1.8 centimetres, so that would be this value here. And the RF we're told is 0.24. 0.24 equals 1.8 divided by our missing value, the distance moved by the solvent. So we just need to rearrange that equation. So we are going to be able to do 1.8 divided by 0.24. That gives us 7.5. So the distance moved by the solvent is 7.5 centimetres. I hope that helps.